Okay, so let's take this problem, for example. Last time in the class, we did this problem, this one here. So this time we are going to do this problem here. Okay, so we would like to express the vector V as the sum of a vector parallel to B and a vector perpendicular to B. Okay, so I took the time to write down the vectors in the next page here and draw some figure to illustrate the problem. So these are the vectors written again here in this page. And we have the this figure here that shows the vectors V and B, and the perpendicular and parallel components of V on B. So this is the parallel component, and it's denoted by V parallel, okay? And this is a perpendicular component, which is denoted by V perpendicular. So the parallel component is nothing but the vector projection of V onto B. Okay, so this is going to be just like previous case, multiplied by, again, B, not without a dot, right? Just multiplication, it's not a dot product, okay? Because this quantity here is a scalar, we cannot dot product it with a vector. So I'm just multiplying it by the vector B divided by its magnitude, okay? Which means the unit vector in the direction of B. So clearly we need to compute this quantity because we are using it twice here. So let's try to find the magnitude of B. The magnitude of B is going to be square root of 4, which is 2 squared. Let's just be more verbose here. 2 squared plus this is coming from here. It's minus 2 squared, which is 2 squared basically. If it is a negative number, then it will eventually become positive because we are squaring it. Plus 4 squared plus 1 squared. And the answer to this is square root of 4 plus 16, 4 plus 16 plus 1, okay? So it's 21, square root of 21, all right? Okay, so B as B as a unit vector, okay, or the unit vector in the direction of B is going to be B divided by the unit vector, the magnitude of B, which is basically minus 2I plus 4J minus K divided by square root of 21. Right? So what we need to do is to dot product this. We can by the way, we can factor out this B here, magnitude of B. We can factor it out outside the product, okay? And then multiply it by itself again, because it's multiplied twice. So we get rid of the square root when we evaluate this expression here. So this V parallel equals 1 over the magnitude of B squared, okay, into B or V, yeah, V, which is 1, 2, 3, dot what? Minus 2, 4, minus 1. Minus 2, 4, minus 1. Okay, and then the we have also the B vector. Okay. Okay, that equals 1 over 21 multiplied by -2 plus -2 is coming from 1 times -2, and then plus 2 times 4, 2 times 4, which is 8, and then minus. Why did I say minus? Because we have a minus sign here. So 3 times -1 is -3. Okay, -3. And we have the B. All right. So the final answer would be, this is going to be 8 minus 5, which is 3. So 3 over 21 is 1/7. So the answer here is B divided by 7. Okay, this is the parallel component. And we know that this component here, the perpendicular component, is equal to what? It's this, because this plus this as a vector addition equals this, then this equals this minus this. Okay, so if you subtract the parallel component from the vector, you get the perpendicular component. So we know that the perpendicular is equal to V minus V parallel, okay, which is what? V, which is 1, 2, 3, yeah. 1, 2, 3 minus the V parallel is B over 7. B over 7. B is 1 over 7 into minus 2, 4, and minus 1. Yeah. So this equals, you can do the computation. Try to pause the video so that I can do the computation and then come back. Okay, so here is the final answer here. We have only to add these two vectors here. Okay, so basically this is going to be 1 minus into minus is a plus, so 1 plus 2 over 7, 1 plus 2 over 7, and then 2 minus 4 over 7, and then 3 minus into minus is plus 1 over 7. So answer is 9 over 7, 10 over 7, and 22 over 7. And for V parallel, we just need to divide B by 7, okay, to get the same answer as provided here, okay. Let me stop recording so that the video doesn't get long.